During my day-to-day work, I love to search for vulnerabilities in different software, especially open source projects where I can see everything that happens under the hood. By the way, if you are interested in CVE hunting, this is a great way to find research targets and get more CVEs to your resume. Recently, I decided to search for projects that already implemented security features in order to measure how well they did this job. And also I wanted to find modern projects and not wasting my time on a 10 years old project with low security expectations, like I had with Impress CMS plugin. And if you want to watch the video about the LFI 0 day that I found there, I will put the link in the description. Anyway, I started looking for SSRF mitigations in Node.js projects with a simple query in GitHub that looks for the word SSRF in the JavaScript language, SSRF, and I also wanted to find this string, which is the IMDS IP address, which is a primary target for SSRF attacks. So let's go to code. And here, one of the things that I looked first was to see how outdated the project is. Now, this is, for example, from August 23, and a few times I searched this way until I found this project hub MCP, which, as you can see, is written in TypeScript and is 3 weeks ago updated. So let's dive into this project. So this project hub MCP by this Anu Bisbee, I hope I pronounce it well, if not I'm so sorry. But this is an enterprise-grade task management web interface with time tracking, workflow template dependency visualization, and team collaboration and many other things, but it's a modern tech stack with outdated commits. As you can see, 3 months ago, most of these commits, some are 4 months ago. And another interesting thing to see here is the contributors. And this user is Bert Colmont, is the main contributor, is the owner of this repository. But as you can see, we can assume that Claude is a lot of AI code that was generated in this project. Now, this is, in simple words, is a project management platform for development teams. And the reason that this repo came up on my search is because of this file here under security utils. And let's look for SSRF with Control F. And you can see that the word SSRF is here 2 times. The first is under this function, and we can see that is valid webhook URL. There are lots of comments in the code. I will assume that many lines of this code probably generated by Claude, and also the comments themselves. Now let's dive into what validation this function does. So it takes a string, this URL string, and it seems like it only allows HTTPS, so it looks for the protocol. And here the real game is starting, because they are trying to prevent it by taking the host name to lowercase, and then the all string manipulations that we can see here is to look for this array of blocked hosts, which is usually a bad idea to use blacklists for mitigating SSRF. But let's move on beyond this localhost block list. And let's take this regex that looks for private IP ranges. And you can see what ranges they are talking about. We can see 10.0.0.0, 172.16, 192.168, and also the IMDS, which we first before. And also it takes the IMDS of Google, of GCP, and it also tries to block this. After the URL string is converted to lowercase and compared with all those regex and strings, we can see that it has some rate limit, and eventually, if all looks good, it returns true. So the next thing that I would like to do is to take this function here, isValid webhook URL, and let's just use GitHub to search where this function shows up in the code. So of course under security utils, like we saw earlier, but we have also this backend fix server.js. Let's dive into this one, and let's Control F and look for this function. And this is here the first time that the function is being invoked. Under a post request to API webhooks, it takes this URL, and if the validation returns false, so it returns this 400 status code, and it tells only HTTPS URLs, 2 public endpoints are allowed, as we saw in the function itself. But let's move on to see where this function also invoked. And this put request to API webhooks and a specific ID in the request. Also, it takes some parameters from the body of the put request, and it also checks for this. But what I'm really looking for is to see when this function not only gives true, but also where this function in server.js actually execute a request in JavaScript. So let's move on. Also add delete, and in another place here we have this also, but here's something interesting happened. It takes this text message, and here, that's what I want to see, because this webhook.url is actually the input that we provided earlier with the address that we want to send a request to. So this fetch method in JavaScript takes the address that we provided after it was sanitized by this isValid webhook URL from securityutils.js and sends the request with post, sends some headers, sends this body that we saw here, this text message. And then if everything is okay, you just update some database records and gives us back a JSON that it was successful. So take a look and think what could go wrong with this request. So in order to test it and let you also test it with your hands, I created another application. Let's go to the Kali machine here, and I literally just took the entire function that sanitizes this input. The only thing that I was changed for this demonstration is this HTTP. It was HTTPS. I, for this demonstration, just wanted it to also take the HTTP, so I won't have to also take a certificate. And the other thing is with this regex, I commented out this IP range. Now, the purpose here is not to show you that I can send a request to this range, but another way that I can use to bypass this entire mitigation in order to access this address, the IMDS, for example. So let's jump to the terminal, ls, and as you can see, we have a Docker file. I, of course, will share this on my GitHub account and see the link in the description. Now, I have this redirect also, which is the malicious server that we are going to use to bypass the SSRF mitigation. So let's just use Docker to run our lab. Looks good. Let's go here to localhost. And as we said earlier, this is the same code of the function that we saw earlier. Now, the second part of this application is this. It takes the URL from the user in here. It goes with a post request to this fetch endpoint, and it takes it through the sanitization of his valid webhook URL. And if all looks good in this function, it takes the URL to fetch with rate limits, which is this function here. And eventually, if everything goes right, it uses fetch with the provided URL to the destination. So let's now jump here and try to use HTTP, and let's go on the IMDS. Oh, sorry. Let's try to fetch, and URL failed, server-side validation. So in theory, if I can take it to my server, to a legitimate IP address or domain, so I will be able to bring back a response of 302, which is a redirect to a different address. So let's jump back to the terminal and let's use Python redirect. And this is on port 8080. And let's take from here our localhost IP address. Let's provide this here and on port 8080. And it looks good, right? Because 404 means that the request is being sent. And let's see here, as you see, we got the request from the Docker container. But here, also take a look on the code of redirect.py. If we go to /subscribe, like I said, we will get the 302 to the location header to localhost 3000, which is the port of the application that is listening on the Node.js. So let's try this again. Let's now fetch it. And yeah, you can see here, we got a response from the Express server, which is our Node.js that uses the Express library. And this is the HTML of this web page. It's just that it got from the localhost, it got from the inside and not from our browser or something. Now, the reason that it worked, even that all the mitigations that we saw in this function, is that actually the fetch function in JavaScript is automatically supports redirects. If you want to stop and mitigate it, you also should do something like redirect, and you have the manual. And this way you will mitigate this attack. And also, this is a very common mistake among developers, because also in Python, the library request, which is the most popular library for making any kind of request, HTTP request in Python, is also automatically supports redirects unless you put it to false. Now, this way you can find lots of projects in GitHub that suffer from the same mistake in various languages. So if you are a CVE hunter, I really recommend you to try this method. And also for Project Hub MCP, well, I did try to warn them about this vulnerability. So I went to their security advisory in GitHub. I read through the security policy that actually looks pretty well, because it's 24 hours for acknowledgement and the initial assessment within 72 hours, but it's not what really happened. I did publish my security advisory about the open redirects in insecure redirects handling, but well, it's still in triage and nothing happened with it. So this project is not very popular in the wild internet, so I feel pretty safe to share this knowledge. But if you want to try yourself this project, the good thing about this open source project is that you can mitigate it yourself with a single line of code in the fetch request under the server.js that make this fetch function. So I hope you learned something new. Let me know if you find something this method, and see you soon.